Hey folks, good morning. My name is Ty Smith. I'm the mobile platform lead for Uber. If you saw the keynote this morning, I roll up under Ollie. We're in the org focused on developer productivity. Today I'm going to talk to you a bit about how we think about library governance and evaluating third-party code. We'll go through some fun stories and kind of the background of how we got here, and then through hopefully a bunch of tactical information that you can take away. This is primarily going to be focused on it from the mobile perspective, where there's a lot of additional constraints that you may not necessarily run into in backend repos, but a lot of this knowledge in general will be applicable. So let's go back in time a little bit into April 2020. I don't know if you remember where you were. COVID had been going on for a month or so. Most companies had moved to work from home. We were trying to figure out if the world was ending. And for us, we got a PagerDuty alert, and we started triaging that immediately, and immediately realized that all of our apps, across 15 or so apps, were crashing on launch. And when we went online, it wasn't just us. The entire world essentially was crashing, all of their Android and iOS apps. Google posted, there was issues posted immediately. If you can see the number of comments here, that quickly went up into the 600 or 700s, and they lost count at 99 plus. So everyone's saying, oh my God, what's happening? Google's, they start triaging and looking into this. Let's walk through a bit of a timeline of what this looked like. So 11:30 a.m., we detected the incident. Google detected it around the same time. They started a server-side rollback a couple hours later after they identified the internal root cause. They told us the rollback had started, but Friday morning, we hadn't seen the crashes stop, and Google updated us and said, actually, you're going to need to release a client-side programmatic fix because there's a specific change that's needed, and we're unable to recover this from the servers. So we started that, and at the same time, we have an alternate mapping product used in some markets called Uber Maps. We generally prioritize Google Maps in most markets, but we started rolling that out as a fallback experience in the markets where we could. We finished the work, started releasing the process for a hotfix. But if you're not a mobile developer, it's important to know that these don't go out instantly. They take a while to roll out on the App Store and then can take several weeks to roll out into the hands of developers. So we'll walk through what that looks like in a little bit, but that's not an immediate fix. Google then released the iOS fix. We put that out. Crashes were still happening. Google then updated us and said, actually, we told you to do one thing. You actually need to do a second thing as well. And so we needed to start a second hotfix. Now we're into 3 days of outages. Then we get into Sunday, where this is cut off a little bit. But you can see here that we rolled out Uber Maps in the remaining areas. And at that point, we had mitigated it. And we move on a little bit here. We can see Google did a public retrospective. They have this out of that doc. It's pretty interesting. You'll see here a timeline of this crash. Here's where they rolled out the issue. The crashes start, they rolled back, and then you see this really long tail of issues here. And this is all of the devices that had cached the result and were continuing to crash until 4 days later, they pushed out an update to GMS core that finally prevented it. So what is the impact of this entire thing? Well, this was pretty much the largest mobile-specific outage that we've ever had at the company. Millions of users were entirely blocked. People couldn't go to work if they were using Uber. If they were drivers, they were unable to work. Millions and millions of dollars were lost, and thousands of hours of dev productivity. Right? We had over 100 people trying to respond to this outage and mitigate and investigate. Talk to Google and talk to partners, and all that was wasted time. We then, did a lot. There's a lot of aftermath. We did a review with our executive leadership. We established new intercompany legal agreements so that we could use Uber Maps in some markets where previously we were prevented. In the case of incidents, we improved our library governance process, which we'll be talking about in a little bit. And we improved our crash protection process, our defensiveness, which we'll also go into some techniques around. And then finally, we improved our crash recovery. So when a crash is actually happening, how can we try to mitigate that a little bit faster? So let's take a step back and let's talk about third-party code as a concept. this, third-party code's great, right? You don't have to write the code yourself. You can use a modern platform, even on, deprecated or legacy devices. You get new features faster development because you're not having to put headcount on it, and, free maintenance and updates. And if you look at, modern Android today, it looks something like this. You have your app code built on an entire stack of third-party libraries that make the modern Android developer experience. Everything from Google's official ones to Square or community ones or JetBrains, Kotlin libraries. And then I like this XKCD comic that kind of describes what this looks like. You have this entire set of infrastructure built on layers of open source, and then one very vulnerable library maintained by one guy in Nebraska. So if you go back to third-party code, there's a lot of benefits, but there's also a lot of potential downsides. A crash in third-party code in a mobile app is a crash in your app. A security vulnerability there is something that you also have a vulnerability for. There's compliance issues or legal problems or permission leakages. All of these sorts of things are problems that you embody when you use that code. And so if we go back to what modern Android development looks like today, I start to wonder if it looks a little bit more like this. So we're going to talk about three pillars of this today. Library governance, or, internally how you evaluate this code and what your process looks like. The defensive techniques you can use programmatically, and then how you recover from crashes more quickly when they happen. So let's start with governance. What is library governance? Well, I asked Bard, and it hallucinated this great example for me. And it seems to make sense. I liked it. So, it's this idea of having a standard process to choose the best quality third-party software, and it, reduces the risk, and it improves your compliance. And sure, it made sense. Thanks, LLM. So if we think about what this looks like in companies, I put this together to think about if you started a small company and moved towards large enterprises, what it may look like when you evaluate third-party code. At a small startup, there's no policy at all. Used what's fastest. You get into, a little bit bigger company, and maybe you have some senior engineers or tech lead who has some opinions, and it's quite subjective, but they drive in a direction. At a medium-sized company, which is kind of where we were at before the Google Maps outage, was, okay, there's maybe a team who owns this, and there's bespoke evaluation and consulting, but, things slip through. And then, finally, at larger companies, you get into this established set of criteria and who's the approvers and what that looks like. So let's walk through setting up library governance at your company. First, you want to thinking about aligning this to your business priorities. All of our businesses are driven by different business metrics, and those may be important to take into account when you establish what the requirements are. Then when you're looking at the libraries themselves, you need to define what the requirements that you depend on. And we'll look at some examples of this in our next slides. Internally, you need to define who are the appropriate decision makers and that they're empowered properly to make sometimes hard decisions. And then what that review process looks like, who's doing the review, how long is that supposed to take, what are SLAs, where's the documentation? And then finally, when things don't work through this process, and you're going to run into this, what exceptions look like. And then finally, similar to introducing new third-party code, how do we think about upgrading existing third-party code? So first, let's talk about the business priorities. Some common ones that you might see at companies when thinking about this are speed to market. They want to ship faster, so they're using an off-the-shelf solution. Developer velocity, they don't want to put their own people on it. The application quality, right? They're picking something that's high quality right off the shelf. It's industry standard. It's well used. And then having a long-term foundation and skill to build on top of. So if we go back to Uber, we used to have this vision that's since gone through corporate rebranding, but I liked this a lot. Transportation is reliable as running water, at least in first world countries. But the idea of reliability, that we have this product that has to be there and reliable because people are potentially using it to go to the hospital, or they're working to put food on their table, or they're commuting to work. Reliability is our top. And so if you think about stack ranking this for how Uber thinks about it, I would put it in this order. And these are all important, but we would say app quality and reliability is number one, followed by having a long-term foundation and scale that we continue to build on top of, and then speed to market, and then finally developer velocity and staffing. So if we move on to thinking about how do we evaluate third-party code, Here's some common categories that we use internally that we expect reviewers to take into account. There's proper licensing. They need to be secure. They need to have, all the privacy concerns taken into account. They need to be stable, both from an API perspective and from like a reliability and crash perspective. And then in Android, you get to interesting caveats where like some things could dynamically update, right? You want to avoid that sort of thing so that it's guaranteed and verified in the testing process. That they're, mature, that they have a good set of maintainers, that they're like the industry standard. If there's 10 different libraries that do the same thing, that they're small. You don't want to increase your application size. And there's several others. And, for your own company, you may remove some of these or add new ones that make sense for you. So moving on into a governance body, right? You need to have some group internally that is empowered, that has executive buy-in, that when hard decisions need to be made where they say, no, I'm sorry, team, you can't use that's respected and that works. And so this could be a platform team, it could be a guild, it could be, some companies, maybe some higher level engineers. But it should be aligned with the stakeholders. It should get the authority. They should really focus on being an enabler over a gatekeeper, right? Even when they are saying no, it shouldn't be, that gatekeeper mentality. It should be understanding what the team's trying to go for and help them get to a solution with alternatives. And, if we look at the process itself of running through that, I threw this word cloud together, trying to think about some of the traits that you would want out of this. We want to think about our developers going through this as understanding the expectations ahead of time so that they're not surprised. That it focuses on education and awareness so that they can walk away knowing how Uber evaluates this, and then they can turn around and educate their peers. That it's reproducible, it's consistent, that if we take 2 libraries through it, they're going to get similar treatment, and that it's injected as early as possible so that people aren't getting thrashed later on. And then, finally, we try to automate and, all of these checks, or most of them, as much as possible. But, of course, exceptions will happen, but they should be very rare. Right. And when they do happen, they should be extremely aligned to the business priorities. We typically focus on the gaps that were emerged during the review process and then focus on mitigation of the risks around those gaps that popped up. And then we heavily emphasize on creating accountability for the teams that are asking for the exception, including, we ask for director level sign off on the owning team and long-term ownership from the team with full-time headcount to account for on-calls and things that they may need to have. And then finally, we use the feedback from that exception to iterate on the overall process for future libraries. So let's move on to the last piece in the governance process, which is upgrades. A popular topic is greenkeeping, or the idea of always keeping your libraries fresh and up to date. If you work in GitHub, you'll often see Dependabot doing automatic upgrades. That can be really helpful. But for mobile, there's a lot of additional risk that we talked about, where you have these binaries that sit out in the wild for a long time, and a crash there is a crash for your users. And there's obviously similar risk when upgrading code as there is in new code. So what we typically focus on is for platform-oriented libraries, things like maybe the Kotlin language or RxJava. We try to keep that as fresh as possible for our developers to always get the latest features. But then for feature-oriented libraries, maybe like a QR code scanner or something like that that's used in an isolated area, we only want that updated intentionally when there's maybe a bug fix that needs to be addressed or a new feature that the team needs to take advantage of. And then it's important to note that there's organizational cost associated with upgrades, right? If you have a large repo, there may be API migrations that need to be done, additional verification that needs to happen, and so that can be very expensive. And then finally, it's worth noting for mobile that a lot of the common motivations for upgrading kind of disappear and take education, like security scanners that are running in your repo detecting vulnerabilities. Well, most vulnerabilities are backend oriented. Things like DDoSes or remote code execution typically aren't relevant for mobile and can just create a lot of noise for the teams that are needing to respond to that. So let's walk through a couple examples of libraries that we evaluated and made decisions on. The first is Coil. It's a popular image loading library used with Jetpack Compose. This was a small library. It had a lot of good traits. I won't go through all of these, but it was, it had good licensing, a good business case. It was small. It was, standard used across all of our peers. It was a pretty easy decision to grant approval for this one. Next, the team came to us and they said, hey, we're the identity team. We want to have login with Facebook. Facebook has an Android and iOS SDK. We want to use that in our mobile apps. There was a good business use case for that. The security checks were passed. It was well tested. But there were several downsides that, we looked at as well. Although it was open source, it had a proprietary license. It was using outside infrastructure, Facebook APIs. Their libraries were fairly complex for what it was doing. And there was a good web alternative feasible. They could use the Safari View Controller or the Chrome Custom tab and have a pretty reasonable user experience. And so we rejected that and worked with the team to roll out the web experience for mobile instead. And fortunately, because a couple months after we rejected this, there was a similar ecosystem-wide outage caused on iOS by the Facebook Auth SDK, and we avoided that one. Let's walk through one more. This is the Twilio Video SDK. This was proposed during COVID because a team that was working on the driver app, the drivers could no longer go to our support centers to get help with their application because of COVID, or it was much more difficult for them. So they wanted to introduce a video sharing and screen sharing so that they could work with a virtual agent and get help. So it was a very compelling business use case for this. But there were a lot of downsides to this one. It was closed source. It was a big black box we were including. It was very large. For mobile, we see about 0.6% user attrition per megabyte on a binary. So 5 megabytes is pretty large. And building an alternative to this was costly. We would have had to, fund this internally, build the full WebRTC streaming team, build all the client-side logic. So, this would have been rejected through the process. But because the business case was so compelling, we worked with the team to find some mitigation strategies. It's closed source, so we met with Twilio. We did a full architecture review, even though we didn't have access to the source. We worked with a third-party security agency. We trained them up on doing a platform review, and they did a white room review of the source code. And then we utilized dynamic feature modules, which is a Google Play feature that allows you to optionally deploy a second part of the binary of the APK later on for only users that need it. And we were able to wrap the SDK inside of that to deploy and keep the binary size out of the main application for most users. And with that, we were able to approve this, and it made it to launch. So let's move on to the second pillar, which is the technical defense strategies in your mobile applications. And so this is entirely focused on Android at this point. It's important to walk through the life of a mobile commit. At Uber, we have a build train. So we have 1 week of active development, followed by a cut of the build train, the beginning of testing and employee and beta rollout. Going into the next week, we have the production rollout that happens progressively. And even when that hits 100, we only see 40% users adopted that, because many users externally, or even if they have auto update on, it may take a long time for them to get all of the latest updates. They may be on poor network conditions in other countries. They may have auto updates disabled. There might be a variety of reasons. But we see it takes up to 4 weeks after launch for over 90% of our users to be on the latest version. And many in that long tail take up to a year to update. So if we think about that long update cycle and the risk that you would have from that if you had some sort of bad, crash in that, we like to think about bugs in general as the Swiss cheese model like they use in security, where you have several filtering mechanisms that catch different traits. And each one of these, is designed to catch a different type of bug, and you layer these on to try to minimize the amount of issues that make it to production. And so when we think about, some of these checks, and we're going to talk about some defense gates here, and there's a lot more than this. This is not an exhaustive list, but these are a handful that I thought were especially useful in talking about third-party code. And so we'll go through a few of these today. We went through the library governance already. We'll talk about a few here, like library abstractions and linters and repackaging, and then a couple in the production rollout here. So let's walk through the first one, feature flags. It's a common concept where you essentially have a server-driven if condition. You say, if this user is applicable for this thing, we enable it. If they're not, we give them some sort of fallback experience. So if we go back to the mobile code and typical usage of a third-party SDK, we might have an activity here and some method that just uses the SDK directly, SDK.doSomething. And if you were to wrap that in a feature flag so that you could disable that in a crash or roll that out incrementally, it might look something more like this, where you check your feature flag API if the user can use this thing, and then you wrap it in an if condition and have a graceful fallback if they're not applicable. So another area that we'll build on with this is crashes at startup, right? So if you look at a lot of third-party code, many of them ask you to initialize the SDK at app startup. So you might see something like this. You have your application process initialization, and on the first lifecycle method on create, it calls mysdk.init. And if there's a crash there, that's really hard to deal with. That crashes your user immediately on app startup. And so if you were to apply the feature flagging logic, you might end up with something like this. You check your feature flag. If it's viable, you init it. Otherwise, you don't. But if you did that, you might immediately see something like this. This is a strict mode violation that says you were doing heavy work on the main thread, blocking the UI thread. This throws in a hard exception in debug. And if you were rolling this out to a customer, this would result in a potential ANR crash and your application startup, or at least a very long blocking startup call. And so you might say, well, why don't I think about concurrency? Why don't I move that to a background thread? So here we added a coroutine dispatcher to our feature flag API. We throw that off to a background thread. When that comes back, they can use the SDK and initialize. And that is a step forward, right? But what we typically recommend is instead of doing this in the application, move this closest to where it's actually being utilized by the user. So understand what the SDK is doing, what the third-party code is doing. And then here we've moved this from application to an activity, assuming that this is an activity that's wrapping the specific third-party functionality that your user is doing. Kind of continuing that train of thought, here's another interesting one we ran into. Here we're including a Gradle dependency for Google Play Services ads library, Google Ads. This is all you need to do to add this to your project. You don't even need to call initialize. And internally, they're doing something really scary. They actually have an XML defined for a content provider, and it gets merged into your manifest. And this runs their initialization code outside of your control. And so if we go look at the docs for the application lifecycle, you'll see this really scary note that the application on create method is called before everything else in your process startup, except for content providers, that thing that just got magically merged into your application without your knowledge. And so its initialization may look like this. Your app starts, it calls the onCreate for inside of Google Ads before any of your code runs, and then your code runs in the application onCreate. So if that crashes, that's entirely outside of your control or ability to feature flag. And so we used an AAPT flag to tell this not to merge and remove this entirely, because we talked with Google, we understood what it was doing, it wasn't actually needed. We could have called the initialization logic on our own later on. They were just doing this optimistically, and we were able to remove that. There's other types of things like that in Android that can run code outside of your knowledge. There's broadcast receivers like we talked about, maybe an intent filter your app merges into the manifest and receives, native callbacks, AIDLs. So this is a general area to be wary of. Let's move on to another scary concept, in my opinion, Google Play Services. Well, why is it scary? One, even though Android is all open source, Play Services is entirely closed source. It's opaque. It runs as a service on your device, as a dedicated process with system-level permissions. It does a lot of stuff that a normal app would not be able to do. It has dynamic behavior outside of your app's control or your app's release cadence. It's updating on its own. They run XPs and feature flags inside of your app, so the behavior may change release to release without your knowledge. And so a typical example of what your app using Play Services libraries may look like is this. You have your app, you use several Play Services libraries, Google Ads, MLKit, Google Pay, and it talks over IPC to the Play Services process that's running, where it's running the business logic, it's doing its updates, it's running feature flags, and your app is consuming that. And so what we've done is we started moving to a model where we're wrapping each one of those in a dynamic feature module that we have more granular control over, that we can install and remove with feature flags and not have that bundled in our class path at all. And this gives us a lot more granular control when something like, maps would be another one of these that we could potentially wrap and remove if there was a crash happening that was outside of our control. So if you look at the APIs for dynamic features, this is kind of a high-level version of that. Here we're using our feature flags. We have two. We have one to check if we should install it, and another to check if we should initialize the SDK. If we should install it, we use the standard APIs to download the APK and install it. Once that's done, if we should initialize it, we also run that code. This gives us great granular control so that if we're investigating issues, we can turn one off and not the other and look into how that works. Let's move on to another concept that we run into, which is transitive dependency conflicts. So here's a common example. You have your app, you have two libraries, foo and bar. Both of them depend on a different version of a library. So what happens here? We see this conflict, RX 2.1 versus 2.2. Well, in Gradle, the default behavior is to use the newest. You can change that with conflict resolution strategies. But still, foo was depending on 2.1. And so this may work fine in your build system, right? Those weren't major changes. Maybe there weren't APIs that changed. But we all know that often runtime changes are nuanced and small, and in large apps, there's a lot of nuance to be had. And so this may crash at runtime. There may be fundamental issues that this causes because foo was depending on 2.1. So you might say, well, why wouldn't it be great if I could have foo use 2.1 and bar use 2.2? And that is possible with jar shading, another concept that is where you can take a set of libraries in a transitive graph and then repackage a specific thing under a different namespace so that you don't get conflict. Here's an example of us doing that with RxJava. So this is great, right? You get stable dependencies. You can use multiple versions in your application. Why wouldn't you want to do this? Well, now you have to bundle multiple dependency graphs. That's going to be much larger. That's going to be more complex. The maintenance of this is going to be pretty challenging. So, I would recommend only using this as a last resort when you couldn't otherwise update the top libraries to use a centralized version. Similarly, in transitive dependency conflicts, we just open sourced a project that we talked about here last year that is a research project to look at complex graphs and try to make decisions if they're going to be compatible or not between transitive dependencies. So I'd recommend checking out this research paper and research project. Let's move on to another topic of defense, abstracting your libraries. So what do I mean by abstractions? Well, I think there's two types. There's the local abstractions in our client code, and then there's the server abstractions. For the local abstractions, this can be really useful if you want to use an unstable API. Maybe it's an alpha API, and you want to wrap that and give it a more stable surface area so that you don't have to eat their migration costs later on. Or if you need to add better testability or feature flagging in a centralized location. Or finally, we often see issues where the third-party SDK is much heavier than we need it to be, and we could write a much lighter weight REST API that hits that service and use that as opposed to the thing that was provided by the vendor. Then we move on into server abstractions, or the idea of taking all the logic out of the client entirely and moving that up to our backend infrastructure. And this can be very preferable because we don't have any of the complexities that come with mobile or the long release cycle or the reliability concerns. Let's talk about one more in this category, linting. This can be really useful for banning known dangerous APIs from third-party code and for shifting potential runtime exceptions in the third-party code into build time exception. Let's walk through a tactical example. Here's Picasso. It's a popular image loading library on Android. Here we're grabbing a URL from the server that we should be showing an image of, and then we use Picasso to load that into one of our views. And we saw a production outage just a few weeks ago where we started seeing illegal argument exceptions pop up. And if you go look at the code of Picasso, they have this assert that verifies that the string is not empty, and it throws a runtime crash. And if you're like us, you may argue, is it really appropriate to have a runtime crash if the image is empty? Like, is that something that users would typically want, or maybe there should be a fallback or not loading the image experience? And you could make the argument that you want the faster feedback, and for many things we do that. But in this case, we decided that not showing the image in that specific screen was much more appropriate than crashing the app and blocking the user. And so we wrote a Kotlin extension function that checks for empty strings, logs it if it is one, but without throwing an exception to the end user. But in debug, it still throws an exception so developers can catch the signal early. And then if it's appropriate, we call the Picasso method. And then we wrote a linter. So we have a shared linter of things that are banned between detect and error prone across Java and Kotlin. And, we were able to then ban this method widely across our entire code base with a message to the developers. So let's move on to the last category, crash recovery. So this is when all of the defense didn't work, and now you're dealing with an outage. So first, let's talk about what's happening in an incident, right? The golden path. Now, if your company doesn't already have this, before we get into any of the other more advanced techniques, establishing a good on-call mechanism, triaging all this stuff is definitely a P0. But what does that golden path look like? Well, a crash starts happening. Yeah, a team gets an on-call alert. They triage the bug. They say, understand where it's coming from, what's going on. Hopefully it was wrapped in a feature flag because on mobile, it's a lot more expensive to do that deployment we talked about. So they're able to roll back the feature flag. Then they monitor. They see the crash is going down. That's great. Hooray. They write a postmortem and they're able to take that forward and fix the bug properly. So the golden path of incidents, right? Well, what happens when that doesn't work? Maybe it wasn't in a feature flag, or maybe it was a startup crash. Well, then it gets a lot more complicated. So we're going to talk a little bit about automated crash recovery, push-based crash recovery. So, we have information and we want to send that to the clients while they're in an off state on the device. A potential improvement we haven't yet built around running in multiple processes on the device. And then if those don't work, how you actually think about the hot fixes in general. So this is a high-level view of our automated crash recovery system, which we call Black Swan. How this works is the application starts, it checks, it creates a file to say, well, the boot has started. It then runs through a series of our business logic startup steps, initializing our DI graph and doing all the business logic you would expect. If there's a crash here, on the next launch, which users typically launch immediately, right? They have an intention to take a ride. Then it starts through this process of running through a set of rules to say, what do I need to do to try to recover from this? What do those rules look like? Well, it's configurable, but in our applications, they typically, on one crash, it retries. On 2 startup crashes, it clears the cache. 3, it starts to clear experiments. 4, it clears data, including like auth tokens. Finally, it has a fallback to the web view. So next one, we talked about server-based rules or push-based recovery, right? So in this case, we have information. We know that a crash is going to happen. A user hasn't experienced it yet. So we want to be able to push a feature flag change beforehand. So we can use like Google Play Push, and we can push a feature flag change. We can also, after the Google Maps outage, where we needed to perform a specific action that was deleting a file, according to Google, we implemented custom recovery actions that we can send through push messaging as well. And then we introduced a new concept recently where we can use a DNS record with a 0 TTL that's kind of an emergency escape hatch where we can have the entire app switch over to Firebase remote config, and we can run some custom recovery actions through that if all of our infrastructures. I talked about a potential improvement we haven't yet built yet. This would be running in 2 processes on Android. So this is kind of an idea of mine that we may eventually fund. But the idea is we would move all that recovery work we talked about, the feature flags, the recovery engine, the DNS stuff, into a separate process. And it could talk to the main app with IPC. And then if the main app dies, this can stay alive. It can continue to report exceptions. It can receive this information. It can try to restart the process. Lastly, if none of that works, you're going to be forced to think about hotfixing and force upgrading your users. Now, it's important for me to reiterate that the real-time mitigations we talked about are much faster. And that hotfixes typically introduce a lot of additional risk. People are under a sense of urgency. They may skip other like code reviews or normal things that you would normally expect. I've seen the incidents where one outage caused another outage because the hotfix was broken. Lastly, we see that force upgrades cause user attrition. If you're dealing with a large application and the user's app is blocking them from using it, saying they need to do an upgrade, and that's a 70 or 80 megabyte application, and they're on bad Wi-Fi, they may just switch over to a competitor. And so with that, we had only 2 technical difficulties while we went through my topic. We covered three pillars: the library governance, the reliability defense, and crash recovery. And with that, I think I'm about at time. So I have a couple minutes for questions. And I now have no final slide with my name on it because it's somewhere in the middle of my deck when it got moved around when I tapped a YubiKey. But we'll call that the end. Thank you.